Hi everyone, welcome back to this channel. Thank you very much for joining us once again. We are still continuing with revising your previous trial exam paper, and today we're going to be looking at this question from the Limpopo province. It's your 2024 pre-trial exam on application of calculus. Guys, if you're new to the channel, please ensure that you have subscribed. Just turn on that notification bell so that you can be notified every time when we upload a new session. Without wasting any time, let's get into it. All right, quite an interesting question. We are given that a chapel window consists of 4 equal rectangles and a semicircle, right? The length of the metal that is being used for the frame is 36 meters. These are very interesting application of calculus question, right? They make sense in real life, right? So they're telling us that the whole metal that will be used, right, to make this frame, it's only 36 meters. We only have 36 meters, right? So the first question, just want you to prove that the area of the frame will be given by this expression here. Okay, so that is it. We are just gonna prove that. So to be able to do that, this is number 1, right? So we know that we have only 2 shapes here, right? You have the rectangle as well as the semicircle. So the semicircle, it's like half a circle, right? That is it. Okay, so and you can see that our area here is expressed in terms of x only. It means that we'll have to go and also express it in terms of x only. That is it. Hence, it's 6 marks. Okay, so obviously the area of this frame will be the same as the area of the rectangle, right? If we take one small rectangle, right, so the area there will be h times what? Times x, the length times breadth, right? H times x. But if we want to include for the entire, remember we are saying for the whole frame, so we were told that there are 4 equal rectangles, so we can just simply multiply this by what? By 4. Okay, so that this can give us the area of the entire rectangle. Okay, maybe some of you might have decided to say, okay, what we can do is we can just calculate this whole length and this, a whole breadth, like that, right? So to say h, this is h as well, x, this is x as well. So you have like 2x, you have like 2h. So the area will be 2h times 2x, which will give you that 4hx that we'll get. Okay, so that is it. Then also plus the area of the semicircle. Okay, half a circle, semicircle is half a circle, so it's half the area of a circle. It's what? It's pi r squared, where r is the radius. Okay, so in this case, half of this, it's this part, which is x, right? This is x. So obviously the radius there will be x. Where there is r, I can just go and substitute with x, then this is squared. Okay, so if we simplify this properly, we have 4hx plus 1 over 2 pi x squared. All right, so now obviously what we have to express it in terms of, it's only x, so we have to obviously go and express h in terms of x, right? How can we express h in terms of x? They've given us useful information here that will enable us to express h in terms of x, right? They've told us that the length of the metal that is being used in the frame is 36 meters. Okay, it means that when you add the length of every part here, right? When you add these, you know, the perimeter, in other words, right? When you add the perimeter of the whole frame, right? Everything, the length of the whole frame, it must be equals to what? 36 meters. Okay, so that will be our second step there. Okay, so I'm just going to use a different color. Let me say the perimeter, which is the length of the whole frame, right, is equals to, if you check here, we have how many h, we have how many x, we have to determine that. We know this is h, 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 this is x, this is x, this is x, this is x, and x and x. Okay, then we have the circumference, the half of the circumference, because it's not a full circle. Okay, that will be that length there. Okay, how many h do we have? You can see we have 1, 2, 3, 4, 5, 6h. 6h plus how many x? 1, 2, 3, 4, 5, 6x is 6x plus, what about this part here? The perimeter of a semicircle. So the perimeter of a full circle will be 2 pi r. Of a half a circle, we have to divide this by what? By 2. So the 2 and 2 will cancel, and we know that r is the radius. In this case, the radius is what? Is x. So you replace that with x. So the 2 and 2 will go away. We are just left with what? With pi x as that portion there on top. Okay, that's the circumference of this circle, of a semicircle. Okay, now we know the perimeter, the length of the whole frame is 36 meter. We can replace here by 36. We have 6h plus 6x plus pi x. I'm not sure if this red color is visible. Okay, then we have to express h in terms of x, so we have to solve for h, right? So I'll transpose this. Minus 6x minus pi x is equals to 6h. Then to solve for h, divide everything by what? By 6. All right, so obviously our h now will be equals to 36 divided by 6 minus 6x will just be x minus 1 over 6 pi x. Okay, so this is our h in terms of x. All right, so what we can do is we can name this equation 2 really, and this was equation 1. We can actually substitute this equation 2 back into equation 1 of our area, so that we have it in terms of x only, right? So we have 4. Where there is h, I'm going to replace the value of h, which is 6 minus x minus 1 over 6 pi x, right? Then we have plus, there is times x, right? Multiply by x plus half pi x squared. Okay, so we can write this properly. 4 times x, it will be 4x into 6 minus x minus 1 over 6 pi x plus 1 over 2 pi x squared. All right. Okay, so if we say 4x times 6, we're gonna get 24, right? 24x. If we say 4x times minus x, we're gonna get minus 4x squared, right? If we say 4x times minus 1 over 6 pi x, it'll be minus 4 over 6 pi x squared plus this 1 over 2 pi x squared. I hope you can see that. Let me just create space. Okay, so I've written it here now. Then we can add like terms, right? Area equals to 24x minus 4x squared. You can see these are actually like terms. Minus 4 over 6 plus 1 over 2, that will give us minus 1 over 6 pi x squared. All right, then we have finally shown that indeed our area is equals to that expression there, which is 24x minus 4x squared minus 1 over 6 pi x squared. Okay, let's go to 10.2. Now 10.2, it's saying determine the length of the base PQ for a maximum area of the window. Okay, this is very important, and now we are applying calculus, right? When we see the maximum area, in other words, what will be the length of PQ, which is your base, which will result in this area of this window to be maximum, right? Okay, now it's the idea of maximization and minimization. We do know that in order to maximize something, and we did this in our session on application of calculus, I'm just going to drop the link on the description if you haven't watched it. Quite an interesting question that people also find it very helpful, right? I'm just going to post it for you to go and watch it to conceptualize this kind of problems. Okay, so if we want to maximize something, what do? We have to find the equation, mathematical equation of something we have to maximize, derive it, equate it to 0, then solve for those variable that will either maximize or minimize. Someone might be asking, why do we have to always find the first derivative when we maximize or minimize? This is coming from the idea that in a cubic function, the maximum value or the minimum value, we get it by saying first derivative is equals to what? Is equals to 0. Then those x that we solve for, right, is the x at the turning point, which is either the maximum or the what? The minimum. So if you want to maximize anything, right, if you have a mathematical equation, you can just derive it and then solve for the variable that will either maximize or minimize. That is what we're going to do as well, right? We want to maximize the what? The area, right? So obviously in this case, this is area in terms of x. We have it 24x minus 4x squared minus pi over 6x squared. All right, so what I'm gonna do, I'm gonna find the derivative of this function 24x. The derivative will be 24 because x will be exponent 0, which is 1. Then this will be minus 4 times 2, which will give me minus 8. Then on the exponent we subtract 1, we'll be left with 1. Then here it will be minus 2 pi over 6. When we multiply that, x exponent 2, we subtract 1, then we are left with that. Okay, so this we can simplify it because minus 2 over 6 is the same as minus 1 over 3. All right, so we have minus 1 over 3 pi x. Then what do? We equate our first derivative to 0, right? Equating this to 0, we have 24 minus 8x minus 1 over 3 pi x is equals to 0. Then we can now finally solve for x, right? How do we solve for x? We can transpose this to that side. We have minus 8x minus 1 over 3 pi x is equals to negative 24, right? Because it is positive, when you transpose it, it will be negative. Okay, so to solve for x, I can take x, the common factor here, right? We have a common factor of x. Then I'll be left with minus 8 minus 1 over 3 pi. Okay, is equals to minus 24. Then to solve for x, I can divide both sides by this, minus 8 minus 1 over 3 pi. Then we can just punch the calculator and finally get the value of what? The value of x. All right. Okay, so when you press the calculator, x will be 2.65, right? If you round it to 2 decimal place, remember this is the length, it's in meters, right? So now the length of the base PQ, now you know that PQ is 2x, is x plus x. Can you see? So now the length of the base PQ, which is 2x, just say 2 times 2.65. Then we can now just multiply that with 2. 2.65 times 2 is going to be 5.3 meters. Okay, so this must be the length of the base PQ that will result in the maximum area of the window. Okay, I hope you find this helpful. Don't forget to like, share, comment, and subscribe. See you soon. Bye.